So hello everyone and welcome back to SWEcodes, and I'm Kaushal Kumar. I'm working as a software engineer in Airbus, and this video is in continuation to binary search series, and we have a very simple problem here where we want to find the first bad version. Let's say what this problem says. So it says like you are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all the versions after a bad versions are also bad. So this is the very important line. All the versions after the bad versions are also bad. And suppose you have n versions of your product and you want to find out the first bad one, which causes all the following ones to be bad. So if I choose this problem because this problem is the direct implementation of our technique. So we are already given an API which will return true or false for a particular version. If we'll apply this method is bad version, it will return whether it's bad or not. So our true condition here is to check whether a version is bad or not, because if a version is bad, then all the versions after that version are also bad. So if we consider versions to bad versions to be a true condition, then we just have to find the first true value, because you just have to find out the first bad version. So it's very easy. So let's try to implement it here. Suppose I have my n versions, suppose 2 3 4 5 6 7 8. Suppose I have 8 versions, and my third version was bad. My third version was bad. So all the versions after 3 will also be bad. All the versions after 3 will also be bad. This we don't care, this would be not bad. Like not bad. Not bad. So suppose we define a method such that if x is bad, x is bad version, then it should return true. So what will be our false and true values will be like something like it is false, and yeah, 3 is the first bad version, so it's true, and all the values, all the versions after 3 will also be true because these all are bad also. And what we need to find is the first bad version. We need to find the first bad version. So it's very easy. It's very easy from our technique, because from our technique we are getting the first true value itself. So if we define our condition such that if a version is bad, then it's true, our condition returns true, then we just need to find the first true value. And if you're finding first true value is very easy with our technique. So let's try to implement it very quickly. So we'll have our low value as 1 and our high value as n. Okay, so while low less than high, we'll calculate the mid. High minus low, bad 2. And to check for bad version, we don't have to implement anything because question already provides this API. This is already provided for us. So we just have to apply is bad version. So if mid is bad version, then we know that everything on the right of mid is also bad, but we don't know whether this mid is the first bad or not. So we'll keep high equals to mid. Otherwise we'll increase our low to mid plus 1. At the end will the low will point to the first true value. At the end the low will be pointing to the first true value. So our answer would be low. Let's try to run it. Yeah, it's accepted. Let's try to submit it. Yeah, you see it's accepted. This bit's 100%. So this feature is fooling us, so don't worry about it. But yeah, if your algorithm is good, then it should definitely be good. So you see it's a very easy problem, and it is the direct implementation of our technique where we want to find the first bad version. So we have to keep in mind, like if it is a bad version, we'll define it as true condition, because the question itself defines monotonicity. Like if a version is bad, then the all versions after that bad version are also bad. So we just wanted to find the first bad version. So you see, it's very easy problem with our technique. And so if you love this video, please do like, share and subscribe the channel, and please do share your feedbacks on the comments. See you in the next video.